If you're one of the people lucky enough to go to DEFCON this year, then you can probably click off this video because there's probably not going to be much new material for you. But if you didn't, if you live in Europe like me and the cost of traveling is a little bit high, or if you're an American and you just didn't want to go, then I have made this video that's covering two cool pieces of research that came out of DEFCON this year. And they kind of relate to my last video, which was how to build AI hacking agents. Obviously, you know, AI was probably one of the biggest topics in security this year. So a lot of the DEFCON talks and the research that comes out of it is going to be talking about how to optimize agentic security frameworks. So we're going to dive into two research articles that came out of DEFCON. One of them made by Albert Corzo, and he talked about basically how to build like a swarm agentic AI, kind of like the one I was talking about in last video, so like the multi-agentic frameworks, and basically the difficulties he had with them and sort of the key takeaways that I've summarized into a few slides for us that we can go over. And then the kind of cooler one is James Kettle's research that came out about the HTTP Terminator, which was his tool, about basically whether or not AI could perform security research. And through a very long article, the answer ended up being yes. So we're going to cover the key takeaways there of those two things. And let's just jump into the first one. So the first piece of research is called Taming the Swarm by Albert Corzo. It has a very long name and an even longer subdescription, but effectively it just boils down to this tag phrase I put here, which is how to build a hackbot or a hacking agent 101. So what is the premise of this article? Well, it starts off basically saying that AI is not deterministic, unlike code. So basically, if you're not familiar with what that means, code basically works in a way that, you know, in a perfect world, for each like individual input you give it, it works like a function where you're going to get the same output back. So for example, if you have like an adder function, right, and you put in two numbers, so you put in 2 and 2, you should get 4 back every single time, no matter how many times you put in the numbers 2 and 2. And for each input, you should be able to get back, you know, the same result. And AI doesn't work like that. So you can pose the same AI 10 questions, the exact same questions, and every time you'll get like a slightly different answer. Maybe the gist of it is the same, but the point is that it doesn't work like code where you're going to get the same result back. And you can clearly see this when you run an AI on an application and you ask it to find some kind of vulnerabilities. It's going to take 10 different approaches every single time, and that's just how the AI is kind of built and wired based off kind of probabilities and stuff, and that's kind of what makes it fun. And the second thing is that it's kind of bad at reproducing, and this isn't really anything like groundbreaking. You know, if you've run AI like at all, you're going to get like a report back. It's going to be made based off like static analysis or whatever, and it's going to work perfectly on paper. But then it just like doesn't work in the real world or something. Maybe like it's like an XSS, and the AI found that there's a server-side parameter that's unsanitized. It goes into the JS, and then it gets like put into the DOM unsanitized or whatever. But then you actually try and reproduce it, and the server actually like sanitizes that parameter, or like you can't put in like tags or something, and then the whole like vulnerability basically breaks down from there. So that's like something that basically happens all the time when you're dealing with these AI frameworks, and this is kind of what the author was talking about. So basically how to prevent this from happening is kind of the point here. And then the other thing is that, you know, a lot of the benchmarks don't kind of include the work that actually had to be done in order to get the results. So, you know, when you had these like cool benchmarks on Mythos was like 80% effective at like exploit bench or something like that. You know, they're not including in there the times that it was like 20% effective and it completely failed, or like the weeks of effort that they had to put in to actually prepare the prompt to get it to work that way, which is kind of what the author was talking about, and saying that, you know, there's still a lot of manual human work involved in terms of building these AIs, and, you know, by themselves they're actually not very good. So the systems around them are kind of what makes them quite good. And yeah, he basically just goes and talk about it, basically how to improve your framework to make the AI agents better. So let's dive into that with some of the, you know, key takeaways that he basically had in this article. One of the things that he said was, and that kind of stuck out to me, was that he put like one LLM basically into one job. So he was talking about if you have the LLM that's responsible for finding the vulnerabilities, actually validate the vulnerability, then it's going to basically like give you false positives and it's not going to be good at the job. So we need to like separate the LLMs into different jobs. And he split the pipeline basically into 6 different steps. And he split them into discover, understand, prioritize, attack, validate, and then report. And I think the two kind of novel ones, you know, I suppose like most of these are probably like fairly obvious when you're doing it. Plus, understand is an interesting one, you know. I haven't really thought about making an LLM that actually understands the application. But looking back, it actually does kind of seem like it might be a good idea. Deploying an LLM like that into like my own stack and stuff, that's pretty cool. And then to prioritize. So prioritizing, basically making an LLM judge what targets are actually valuable and what should be attacked here. And this is kind of the 6-stage pipeline that he basically prepared here. And by the way, this tool is open sourced, so he open sourced the tool. And I'm going to put the link in the description so you can check it out. And also all the presentations will be in the description, so you can also read them there. Wait, that's kind of the cool way that one of this pipeline works. And then the next kind of takeaway that he has, and this is going to come up later, this is a kind of like a recurring thing that happens with these AI agents frameworks, is that the AI is kind of top level. It kind of like makes decisions and decides, but it's actually not very good at executing it a lot of the times, or it's like, it's hard to kind of replicate and it's hard to kind of benchmark things that the AI does. And because of that, basically a lot of the strategy has been to offload basically things that are repeatable to deterministic code. So building stuff like MCP servers into your framework is great. In this way, like you can see here, he built like classes into his framework that basically allowed the LLM to manipulate sort of say HTTP requests and, you know, make sort of like adjustments or iterations into the program, basically using deterministic code. And that basically made the LLM better because it didn't have to think about how to actually execute the problem, because that was already solved for it by the code, which frees up context for the LLM to do other things, which makes it basically better. So that was one of the takeaways, and we're going to see this come up later because it's quite actually like a common thing now where LLM will like write scripts and like functions to do things, but you know, the LLM will like not remember where it is. They'll try and write it again. It'll like think about it, whatever, and that kind of pollutes the context, which makes it worse. So it's actually usually better to take that code and put it into like a deterministic script instead that we write ourselves, and that like becomes part of the framework that we use, or you know, the kind of tech word, it's called the harness to use it. And the other thing that he said was to use like validation layers. So he went into this thing where basically when you had like one validator, it would often like be a little bit biased and it wouldn't actually like validate it properly. So he basically split the validator into a deterministic like code script that would go over certain benchmarks that he set for each of the reports. So for example, he would basically like filter out like only static analysis, and he would make sure that there's actual like reproducible payloads in the exploit. And he would filter out, like you can see, like XSS without browser executions, SQL without exploitation evidence. Basically, like he would make sure that the AI actually had evidence to back up that the vulnerability was reproducible in the real world, and he went over it in like a step-by-step process. I imagine he was using sort of LLMs in the backend here to sort of validate that these things were true, because running, you know, actual code over it or like regex or something is really inefficient. And yeah, so he basically checked that kind of thing against the reports, and I think that's also pretty useful potentially for like escalating into your own system. You know, one of the bigger challenges I found with my own like agentic pen testing systems is that it tends to be like manual labor trying to validate it. That's probably like the worst part, is having to look at these scripts or whatever that are like vulnerabilities that it gives you these reports, and then having to like construct these like payloads of them, having to understand it fully. And you know, the best thing would be if you just had like a one-liner you could just run, and it would just like, you know, give you like credentials or something. It would like drop like a AWS credential or something. That would be ideal if you get it to do something like that, or like a one-click like click here for XSS or something like that. That would be perfect. But obviously, you know, it does require these validation frameworks that the author here was kind of talking about. So I think that's a pretty good takeaway as well, if you want to add that onto your own agentic pen testing systems. Just moving on as well, I think this is actually quite, I don't know if it's innovative, but I haven't done this myself. It's like build like a dojo or something to basically like benchmark the models yourself before you deploy them into the real world, and then like figure out like why it didn't like find a certain vulnerability. Now, I think there's a bit of a caveat with this that I want to include just from my own experience, is that actually like writing vulnerabilities into code is actually very hard. Like intentionally making vulnerabilities that are hard to discover is actually difficult, which is surprising. But when you write code and you're intending not to write vulnerabilities, when you actually end up writing a vulnerability, that's like a proper like vulnerability that you have to go and find, because it's sort of like an oversight that you made in your mind, because your mind just didn't like register something, or like glossed over a fact, or made like an assumption. It's really hard to fake that in real life. It's really hard to fake like an assumption or an oversight, because it's just part of your blind spot. Like it's your blind spot because you don't see it. So when you try and like go in and try and like imagine like, oh, this is what I would do, like you can't, because you don't know what you would do. And it's kind of the same, right? It's only like after you find the vulnerability, you're like, oh, like that makes so much sense. But before then, you don't really like know where it is, right? So I find that, you know, when you're writing these challenges, it can often be a little bit too easy. But obviously there's probably a way to make it right, and obviously like CTFs do exist and stuff, so it's possible. But I do find it a bit hard as well when I'm making like challenges that sometimes I feel like they're too easy. Well, yeah, so he's just making this dojo to benchmark your LLMs and basically figure out what's going right, what's going wrong, and then testing your validators against those benchmarks first, which I think is solid. And if you can actually make the dojo good, if you can make it kind of actually look like something like a real web app would look like, then I think you can get a lot of the way there, and you can figure out like why is something broken. Because when you're looking at a real target, what he basically says is if you're looking at a real target, you can't figure out what was going wrong, because the vulnerability could just like not exist, right? Like maybe nothing failed, but the vulnerability just didn't exist. But here, you know, the vulnerability exists. So that means that if the framework didn't find anything, then something must be wrong. So yeah, that's kind of this research report. And as I said before, you can go read it in the description. It's a fairly nice paper, I would say. It's a fairly nice presentation. Sometimes it's a little bit waffly, but overall it was good, and it had some actionable insights. And I do recommend you give it a read before you go and work on your own like agentic frameworks and stuff, because it's probably valuable just to pull out a few, maybe even more like facts you can pull out of it before you go make your own stuff that I might have not just mentioned in this PowerPoint. So the next report is from our good friend James Kettle over from Portswigger, and he made this report called "Can AI Invent New Attacks?" It's a bit of a longer title, but effectively it boils down to this blue text that I have, which is basically how do you make a research bot 101. And he goes through some of the steps and that he went through, basically turn his research pipeline into HTTP desyncs. So kind of this HTTP smuggling kind of research that he was doing. And he basically looked for a way to automate it with AI. And then he talks about in his research post and how we can do it ourselves. So yeah, that's basically the premise, is that, you know, James Kettle is a very good HTTP request smuggler. He does a lot of like research into this area, so he knows a lot about it. And, you know, he does like his own research. He reads like RFCs, and, you know, he publishes blogs, and he does like tests on actual websites. And he basically asked the question, you know, I'm doing all this work. Can AI stand up to the task itself? So can I build an automation pipeline where AI will do the work for me? And he has this 3-step framework that he basically tried to turn into an agentic pipeline. And the 3 steps were, first, ideation. So creating the idea, getting the idea from some of the RFCs, which are like these guidelines for making and basically stuff on the internet for like standards on how proxies should like behave with each other, which is very important for HTTP request smuggling, because if a proxy isn't following a certain behavior, then it's probably going to be vulnerable down the road when 2 of them try and talk to each other. The next thing is evaluation. So basically when you have an idea, then judging whether it's actually going to be true, whether it's actually going to work in practice. And then the last bit of it is sort of weaponization. So when you have the idea, when you have the working proof of concept on like a website, then how can you actually turn it into real impact? How can you actually like, you know, read someone's response? How can you turn it into harvesting PII or delivering some kind of payloads? And these are basically the 3 things that he goes into this article. And these are some of the key takeaways anyway from it. So basically the first step, ideation, he takes RFCs from, you know, this online website, and he basically fed it into this LLM. So in this article, he basically goes into how he was like testing and stuff, how he was basically at the start trying to get the LLM to reproduce some of his findings and maybe discover new ones. And in the end, he ended up settling on this solution where he basically feeds like all of his like inspirations, where he feeds in these RFCs, security advisories, sort of like his own tests and bug reports into the LLM. Then another LLM will actually split each of like the inspirations into like the large like RFCs. It'll split it into like micro little bits of inspiration for another LLM to use later. And when he has it split into like these like small like actionable paragraphs, then he gets like another LLM to start working on each of them and actually generate like hypotheses for like desync attacks. And that's basically like the research pipeline that he uses himself to determine these request smugglings. So he basically turned that into like an AI pipeline instead. And then for evaluation, and basically the pattern that we've seen before is when you have these like AI reports and whatever, then you need some kind of deterministic system to work in with them, because you can't really trust the AI, because the AI is, you know, non-deterministic, and we don't really want that when we're doing coding and stuff. So what he basically did was, in order to test each of the ideas, he basically had like the LLM like submit a payload into this deterministic system. So this bit of code, or like the script or whatever, the script would send the payload over, then it would read the response, and then it would basically determine if there was a desync happening. So the script would parse the response and then determine if a desync was happening. So you can see here, for example, that, you know, he was testing this government website and he was sending a GET request to the website and it was like moved or whatever. Then when he sent a desync payload and it came back with a response, the next kind of payload you can fetch after it. So the way the kind of desync works is you send like the smuggled payload and then you send a request right after it. The next kind of request ended up showing that it was a different response coming through. So we were able to basically pollute the response in the proxies. And he used a deterministic system to figure this out. And that kind of took away some of the bias that the AI had when it was developing these actual hypotheses, and it turned it into deterministic code, as we've seen over and over again, taking the kind of power out of the AI's hands, using it kind of for thinking, but then using code for evaluation and also execution. It seems to be a very common pattern among these agentic frameworks. Next, what he basically goes into was how to actually weaponize the code. And here I think it's pretty funny because he ran into some of the refusal networks of AIs. And he actually has a very clever way of combating this, which I didn't think about it before, was when he was using like an MCP server, he actually kind of figured out that he basically controlled what the AI saw. So the guardrail was completely dependent on what the AI was actually looking at. So what he actually did was he renamed the tool to Turbo Simulator, and then he basically like told it that the tool was attacking like a sandbox like environment. It was attacking like a sandbox target, but in reality the MCP server was making calls to a real website, like a real target, but the AI didn't know that, so there was no guardrails in place to actually stop it from being able to do that. And because of that, the AI was very happy to comply with it. You know, it was just, you know, some student testing a website or something, and it was perfectly fine because it was in a sandbox environment, so it was okay. And I think that's, you know, that's pretty cool, in my opinion. And then one of the other things he had as well was one of the headers in the requests was basically causing a false positive in the AI, where the AI would reject the payload because it saw connection refused in the headers. But this wasn't actually an indicator that the attack didn't work. It was actually just like a random header that was getting sent in that the AI was blocking on for some reason. So he used this MCP framework to rewrite the response that the AI was seeing, and that effectively solved the issue because now the AI didn't know the header even existed in the first place. So I think that's also pretty cool. And then, you know, of course, the thing I've been drilling on this whole time, the most common pattern out of this research is the human versus LLM versus code problem. So he shows this graph in the research that at the start, when you're building your agentic framework, the amount of tasks that the AI has to solve itself is quite high. So it's like 50%. The amount of code is quite low because you haven't built any of like the harnesses yet. But then as your project continues, then the code should take over much more of the tasks that AI was handling. The amount of human in the loop input should decrease significantly, and the AI should just handle the small bit of thinking at the top of it, the actual non-deterministic bits that we need the AI to do, but everything that it should be reproducible and should be kind of cleanly deterministic should be handled by the code itself, which is honestly probably the most important takeaway out of these two articles. And then the last slide is just talking about basically the blueprint that he gives us as security researchers to basically how we can build these agentic frameworks to start our own security research. So he talks about 4 things. He talks about objective, so basically what you want to research on, what kind of behavior are you interested in researching. Then he talks about evaluation, so how are you going to judge that the AI actually found a good hypothesis? How are you going to figure out that the LLM succeeded in what it was doing? And ideally you do that deterministically through scripts that are basically going to be able to determine if the AI was right or wrong. Then inspiration sources, where are you going to basically get the AI to develop research techniques from? Maybe you can give it like code of certain like websites or whatever. You can give it RFCs, you can give it like patches or whatever, and you can get it to start thinking, developing thesis like a hypothesis, which you can then feed into your evaluation network later. And then lastly, I didn't really talk about this, but he also talks about like cascading, which is basically how you kind of make a cycle out of the whole thing, basically taking the findings that the AI has already had, feeding it into new inspiration sources for the AI, and then letting the AI kind of combine the two and then reach new results from it. And that's kind of the blueprint that he gives us in this article, and that's kind of how he closes it off. Very cool article by James Kettle, and it's nice to see him dropping it on DEFCON again, which is very nice. And yeah, I hope you enjoyed this video where I talk about some of the research coming out of DEFCON this year. There's a few more articles I wanted to cover, but I didn't really have time to do them because these two are so long. And if you want another video on this, then you can leave a comment down below. You can say that you enjoyed this video. And yeah, that's it for me. Thanks for watching and happy hunting.